Claude Code now orchestrates agents. You ask it to build a feature, it will write it, it will test it. They even offer the Claude Code review that can review it. It's getting smarter by the day, and it is amazing, and you should definitely take advantage of it. But here's the scary part. If you don't know what it does, it can be non-deterministic, as we've seen before. You might get one thing one day, another thing another day. How do you ensure that it safeguards? How do you know what it actually does? I'm an engineer. I like to understand how things are built. I like to be able to have consistency and ensure I get production-grade code. For someone just vibe coding, it's fine. But what about bigger teams and products that matter? This is why I set up my own workflow. And this workflow is built upon engineering best practices where we generate the feature, we test. It has a self-healing loops because that is the future, self-healing loops. Code that can run and run in a cycle. That's how we reduce hallucinations. That's how we get better quality code. And I've built a little workflow. And I want to share that workflow. It doesn't mean you need to use my workflow. You can invent your own, and this is where the world is going. Everyone's going to orchestrate a little differently. That's fine. But my encouragement to you is build a process that works for you. Take upon best practices. Make sure you get consistent results each time. That is not what we have today. It's a wild, wild west. And if you don't watch out, you're going to be bitten by it. I'm sure of it. I can't tell you how, where, or when, but it will create a lot of mess unless you control it. We've seen that with LLMs constantly, with slop and vibe coding. So this is why my example workflow shows you one way. I'm going to run a simple TDD where you kind of build an agent, it tests itself, it writes the code, there's specific roles, and I encourage you to start thinking in terms of roles and orchestrations. And if you don't know, ask someone or look in repos, mine or others. There's a bunch of them out there, and we're going to see more and more of them. So without further ado, let me jump in, and I'm going to share a repo at the end of this. Please click like and subscribe. That's what helps me keep this going. I hope this helps you guys as we all figure out how to navigate the world of AI. So let's jump into a quick demo to see my workflow, what's consistent about it, and how I like to build software with this new agent orchestration. So before we jump into a demo, I want to walk you through the project structure of what I have here. So there's a README that describes everything, so if you don't know, you can always go through the README. First, there's a convention folder, and in the convention folder, there's some Python conventions. This one is a minimal. It talks about type hints and paths and logging, but you can put whatever conventions you want to be enforced, and you can even have a few of them for different languages, etc. So this is just a sample and an example of how to set up a workflow. I've created a couple of agents. So first we have an SDE, and this is the idea that it doesn't just launch its own agents. This one describes the project structure, it has execution rules, it has workflows on how to create stuff. And this is a very simplified SDE. I would actually add in more, and it tells it to use the coding standards from the Python. And then we have a test engineer that kind of tells it to analyze tests, create a plan, set up how to write tests, what to do, what not to do, and then coding standards, again, reference the coding standards. So we're creating this overall project structure that links and interlinks, and that provides a lot of value moving forward. In addition, there's a bunch of skills. So let's kind of walk through the skills. First, the review skill points back to the review from the code reviewer, and that basically runs a review. It sends a diff on your project tree of what's not checked in. It sends that to Codex to perform a review with a do and a don't. We have a skill that does run tests. This one looks for a project structure and will actually run the tests, meaning we're going to get repeated skills, and this makes it easy for the agent, sub-agents, or yourself to do a run test, and it will just run the test rather than do it independently. We have a Python reviewer that will get back to that, and I'm just going to talk about Dev App Fast just writes a feature and then kind of has some tests, whereas Dev TDD does that the other way around. It adds that, it creates a plan. Again, I'm always telling it to plan, then I tell it to write tests to run the test, then use the SDE to look at the code, fix the code, and then test in a loop 3 times. We don't want it to run forever and need all your tokens. And then I want to run the code review, which again, we've seen in the previous video, it feeds that into it. So that will be able to create a self-healing loop. And the last part is the skill for the Python reviewer. The Python reviewer collects the diff, runs some static tool, launches the review in the background, runs analysis, and also looks at particulars from against the coding standard. So all of those work together in unison, and this is a simple workflow. We're going to see a lot of different workflows. I'm going to show you ones that I use. I encourage you again to look at, adopt others. This is where we're all learning together. No one knows the answer. This is something that I personally find brings me a lot more consistency in the code that I generate. And I think having these very specific workflows creates uniformity across the team, how people use Claude Code, and not having everyone run their own and rely on Claude Code to invent its own. This creates uniformity, predictability, and also enables you to control what it does, and how it executes. So now I'm going to jump in and show you a demo of how it is to write with. And so in order to demo how this TDD and the multi-orchestration with the self-healing loop works, I've created a simple app. It has load tasks, save tasks, add a task, and then list tasks, complete tasks. This is like a little task or a to-do that is missing delete. And we're going to add the delete first on a branch with no Claude Code orchestration, using the orchestration I created here, and then the second flow is going to be using this TDD flow. So the first one is a vibe coding. I'll show you how that's done, and then we'll run through the second one. All right, so now we're on a branch, we're on a clean branch, and now I'm just going to ask it. And I'm just asking it to do a delete. It didn't check, it didn't review, it didn't do anything, it just wrote code and off we go. And if you know that the cost of finding bugs later in production is a lot more expensive. So this is an example of vibe coding. Now let's demo the other process. Okay, now I created another branch and now I'll do that. Now I'm letting it run with a dev TDD. Very similar to the vibe coding I do on, and then look, it enters phase one where it's planning. So first it's going to plan the feature, it's going to think through that. And again, this is a tiny little code base, but just the fact that it does planning approaches the orchestration in a very, very different manner. So now it's looking at all the stuff that we have, it's looking for the tests folder. It's asking, is the plan okay? Look at the difference. It's telling you what it's going to create. Even if you don't know, it's going to do that. It's going to share the fixture of the JSON store. It's going to add 7 test cases. Let's do this. Run tests. We should see failures. Errors. You can see one error. A whole bunch of errors. It kind of failed right away. Now it's using the SD to write the code itself. This is the proper way to create software engineering. Look at the difference between how much lift it does when we tell it the orchestration versus when we don't. Now the test loop. Now it's finished, it's going to run and iterate. All tests are passing. Good. Now it's running a code review on it. It's reviewing its own code. This is how we produce production grade. No issues found. This is very simple code. In other cases, it would find it, it will run that. In this case, it all went through. It's a very, very simple feature. In other cases, it will find reviews. It will actually fix itself. We'll look in a second on how to do that loop where it fixes it. Completed. It's got 7 files. It just created production-grade code with tests, did a code review on itself, and if it found issues, it would send it to itself to rerun the fixes. This is how we produce production-grade code. You don't have to follow my orchestration, but you got to start thinking in terms of orchestration consistency. How do we ensure our agent behaves properly? Whether it's tool permission, whether it's production code and creating the same flows each time, how do we create these loops? How do we have the agent go back and fix itself to create high quality code? And now let's look at the final produce. So you see, the code that was created was not so significantly different, but just the fact that he thought through that, it worked through the problem, then it actually created tests that will actually verify that it's shared and all the functionality shared in a conf test with a fixture shows that it's starting to think like an engineer. So we can make our AI think like a proper engineer or not. Vibe coding goes off and does whatever. Here we're giving it a lot more thought. We asked it to make a much heavier lift, and the quality that we got out is completely different in terms of a flow. While this is a very simple example, if we make it slightly more complex, it will find issues, it will go through it, and it will produce you production grade code. And that is what we want, to use AI to create production grade code. So I hope this is helpful. Click like and subscribe, grab the repo, send me any questions. Hope this helps, and I'll catch you in the next video.